Okay. All right, folks. So let's go ahead and get started with the lab itself. So again, Hooke's Law, page 41. The first thing we're going to do is we're going to investigate the behavior of these little springs here. So we're going to try to do our best to estimate simply from using certain masses and displacements what kind of spring constant our spring is going to have here. So what we're going to, just to show you how our experiment is set up, we have this force sensor. You may remember from the centripetal motion, we had this a string tugging on this guy. And we also have down here, let me tilt this down, this is the motion recorder, motion sensor we used for the first two labs with the track. So that's what that is. And basically, the first part of our experiment, we're just going to not use Pasco. We're not going to take data electronically. We're just going to measure it with, use predetermined masses and measure displacements. However, later on, we'll be measuring how the spring changes distance from the motion sensor based on what kind of force is being exhibited by the spring. So we'll start there with just more of the analog measurements. So to start off, we've attached our first spring. Now we're assuming these two are identical. So we've attached it to the force sensor, and we'll get started by, as it says, finding the theoretical spring constant K theo, and we'll suspend the mass holder from the spring. Now, just so everyone knows, this mass holder, probably not going to be able to see that, but it's 25 grams. So you'll want to write that down. 25 grams for the mass holder, and we'll just suspend it from the spring like that. And so the very first thing we'll need to do is to measure what height our the bottom of our mass holder is. Of course, you can see it's oscillating. That's actually another use of springs. They have a kind of a steady shaking motion depending on the spring constant. That if you go to some higher level physics classes, you'll hear all about that. We're skipping that lab due to the extended spring break, but it's just good to know that that's how these things work. So the next thing I'm going to do is I'm going to measure with, again, 25 gram weight, with 25 gram mass. Sorry, folks. You should not confuse masses with weights. In physics at least. With, again, 25 grams, we're doing a reading of, I'm going to call that 20.8 centimeters. Now, so you'll want to write that down in your data table and note that in the data table 1, you're asked to put that distance in meters. That's to make the calculations easier. If you want to change it to centimeters and convert later, that's up to you. But again, 20.8 centimeters. Was that? I'm pretty sure it's 20.8. Let's measure one more time. No, it's 20.8. All right, so it looks like it's about 20.8, 20.9 centimeters. Feel free to use either one of those measurements simply because it's not, it's moving. It's not quite perfectly easy to tell which of those distances it is. You'll record that displacement or that the height of this and realize that that's not the distance that the spring is being displaced. It's just the height of the bottom of the mass holder from the table. And so there's going to be another set of data as well available on Blackboard. You can use either one of these. They'll both give you, good results. It's just a matter of which one you choose. I've lowered this one now so that you can see the experiment in action. Now, the next thing we'll do is we'll place an additional 10 grams. Remember, the mass holder itself is 25 grams, so 25 plus 10 grams, 35 grams total hanging from that spring. And we'll see how far the mass is now from the bottom of from the table to the bottom of the mass holder. And that has given us a distance of, I'm going to call that 18.9 centimeters. Your length 2 should be 18.9 centimeters if you choose to use the measurements in this video. Again, you can use the measurements I collected earlier as well, up to you. So that will give you all the information you need for data table 1. Do note, however, that you do have to calculate the force, and the force is not simply equal to the masses. You'll have to use, just remember the gravitational force from a certain hanging suspended mass to calculate what the force that spring is going to experience. Find those forces, find the lengths, and calculate those forces and put those in your lab report. And then you'll move to data table 2. And in data table 2, we'll figure out the different distances the spring was extended, and compare that with the distances, the forces the spring experienced. And just again, a reminder here that the distance from the bottom of from the top of the table to the bottom of the mass holder is not the distance the spring was compressed. So if you're getting negative numbers, you'll probably have to reconsider what's going on there. So be sure to be careful with how you're setting this up so that you're capturing how far the spring is getting displaced in each of the trials.